Analytics. Today we have two special guests on our new entrepreneurship series. We have both Tahmeed and also Alan with us, and they are the co-founders of Dawn Robotics. How are you guys?
Great, man. Thank you so much for having us in your podcast.
Great, great. Do you want to just introduce yourself? Yeah, Tahmeed, go ahead.
Yeah, absolutely, man. So, hey, Tahmeed, founder. We founded Dawn Robotics. So I'll just go a bit into our background. I studied mechanical engineering in the University of Toronto and went on to work in basically robotic automation for medical devices. Basically, automating some of the work done by lab techs and biotech people. And yeah, I've been working there for the last 3 years as a product engineer. And now we've decided to start our new venture in robotics. So I'll let my co-founder Alan introduce himself as well.
Sure. My name is Alan Lee. I also did my undergrad at U of T in engineering science. And currently I'm actually a PhD candidate working in computer vision and robotics. I've basically, my experience is research and also around 7 years of industry experience in industrial automation and manufacturing.
Great, great.
Yeah, he's a very humble guy, but he's a robot god. Don't let him fool you. You know what I mean?
Well, we'll talk more about it. So yeah, so what are you guys working on? What is Dawn Robotics like?
Sure. So Dawn Robotics, we're basically providing. We're using we're creating next generation computer vision platforms for robotics purposes. So we have this next generation markers, which is specially made so that robots are able to, manipulate any object these markers are on. So just to go a bit into like the history of these passive marker systems, you know what barcodes are, right? They're basically everywhere. But all these barcodes do is carry a string of numbers. You can scan it, you'll get a string of numbers, and that's like the basic 1D passive marker. Now you have like 2D markers, right? You have QR codes, you have April tags. These are basically, instead of a straight bar, you have a little square-shaped thing. And these basically carry information. These kind of markers are used in robotics for basically robots to understand where something is positioned. So for example, if a robot wants to pick up a box, you can put these basically 2D QR code-like tags onto these boxes, and then a robot is going to come in, pick it up. But there's a lot of problems with this method. I don't know if you ever tried to scan a QR code on a flat surface. If it's sort of somewhat bendy or if some parts of it are blocked, try scanning a QR code. It's not going to work.
Okay.
That's basically why, robotics is very limited when it relies on QR or 2D matrix markers. You know what I mean? Any sort of deformations, any sort of surface curvature, any part is blocked, a robot's basically turned blind. It can't see the QR code anymore. And that's why we basically create a new marker design, which sort of works under heavy occlusion, works in these real life situations. You'll see in a factory, you'll see in a warehouse. It basically, it'll allow a robot to see objects of any shape. It doesn't have to be uniform. It doesn't have to be, hard-coded in there, complete. Any surface shape you put this marker around, robots will be able to see it. And that's what we have already accomplished and what we are sort of pushing forward with.
Wow, that's awesome. So I guess what triggered you to, come up with that idea? Was it your background, or was it, what you guys were doing already and you just saw this opportunity? How did it trigger that idea, the ideation?
Great question, because the story is very long and winded, my guy. So we actually didn't start by thinking, we're going to improve markers for robotics. What we started off with, we wanted to create this augmented reality guidance system to help in sort of medical procedures. So what we wanted to do that, we had to basically track a suture thread, a very thin suture thread. And that took us a long time to achieve, but we were able to achieve it. There's through heavy occlusion, we'll show you some demos of that later. It's extremely cool. through heavy occlusions, through multiple knots, we were able to achieve it. But then when you have a single string, right?
Basically, it was the first iteration of our marker design that we built to accomplish this tracking for the thread, really thin thread.
So now that you have a string, if you can basically multiply that tracking, stack up these strings, you can basically track anything.
You can track any surface.
Any surface.
Like any surface is just can be just broken down into a combination of strings, right?
Got it.
So when we were able to achieve that, we knew we still did something bigger. AR guidance is cool and everything, but we realized, wait, we can apply this right now. This is a huge problem in robotics. The reason why Amazon still has workers sorting different multiple boxes is because robots can't do that. Multiple packages come up, multiple size stuff come up. Like if you get a package like this, which is like bendable, you know what I mean? You can't use a QR code on that. Robots can't handle that. You need.
Yeah, can you share? I guess can you share? Assuming most of our viewers are pretty new to robotics in general. Like, can you share some of the you see application uses? I think that would definitely.
Yeah. So currently, actually, one of the very boring tasks, but tasks that require humans, at least currently in Amazon factories, is just picking up a package, finding the QR code and then scanning it.
Let me see if I can show it to you a bit better. Do you see the QR code here?
Yeah.
So what people have to do is just pick up these packages, scan the QR code, and then put it into the right bin. It's currently you can't automate it because there's too many different types of packages coming in, too many different shapes and sizes.
Because the robot basically isn't able to find this QR code because it needs to detect it, right? But if it's
bent, right? It's bent.
There's no way of detecting it.
Yeah. So what we can do is basically, instead of a QR code, we'll have the same information a QR code does. But what we'll do is we'll work even under these deformed conditions. You know what I mean? We'll work under any real life situation. And we can do this in real time as well.
Yeah.
So now that huge part is, there's options for automating that huge part now.
Yeah. And I think one of the things we sort of chatted before, right? You said it could actually have healthcare applications.
Absolutely. So that's where AR guidance comes in. So when we talk about the healthcare thing, right now, if you want to track tools, tools to show how, for example, if a surgeon wants to show how to perform a specific procedure, what they can do is apply our markers to tools they have, perform the procedure. We'll be able to extract that data of exactly how that doctor is holding those tools, exactly how it's moving through whatever object they're tying up or whatever they're doing, and be able to basically transfer that over into a 3D visualization, like a hologram, basically, And now anybody around the world can see exactly what this expert doctor is doing or this expert surgeon is doing. So that's the AR guidance implications of this. There's AR guidance implications, there's robotics implications, there's digital twin implications. A very rough example is a kid wants to bring their toy to whatever Roblox virtual world. They can just put markers around their teddy bear or any other favorite toy, and now they can bring it into that universe. They can move it around. That perfect replica of that will be moving around the virtual world. So it goes beyond that. One of the people we're talking about wants to use our markers in education because they have virtual reality classes. And what they're really lacking is when you're wearing a VR set and you want to sort of interact with objects in front of you, there's nothing to hold, right? It's all virtual. So it's very difficult to show what you want to do when it's all virtual. Like you think you're grabbing something, but that feeling, the tactile feedback isn't there. But with us, all the objects in front of you, put our markers around it. Now, guess what? As you're interacting with these things in VR, the data is being transferred over. You have that digital twin created in VR as well. What we have is a system, a very low-cost system to track anything. So then now you have applications robotics, applications AR, VR, applications mocap for movies, applications in digital metaverse or whatever they like to call it. So it's a one-for-all solution. That's why we decided to make it into a platform instead. It's a platform where anybody can just use our markers and create their own digital motion capture of what we're doing.
Wow, that's awesome. No, that's exciting stuff. I guess one of my questions. So it sounds like you're already talking to various different customers, right? Who are
Yep.
interested. So you shared like what are some of the industries that like the customers and like
So
I guess yeah, like how's that process going? Yeah, overall.
sure. So right now we're talking to basically logistics companies.
Mm,
There's some companies here which do same day delivery, and they're sort of swamped. They don't have the same capabilities as Amazon. Like Amazon's such a big company; they can hire how many workers they want to, but even then they're like logged up with overflow and such, right?
mhm,
So these smaller companies are facing even worse troubles. So what we're doing is offering them low cost automation solutions using our tracking system. That's one of our customers. The
mhm,
other one is we're looking at is AR VR,
mm,
an education platform which uses our markers so that teachers can bring in their study material into the VR world, and then show how exactly experiments or processes are conducted. So those are two areas of focus we're doing. And
mm.
what we're doing is creating examples, creating some demos for them to show how they can use it. And we would love to show you some of these demos if you'd be interested.
Yeah, no, I think this is a perfect segue. I think we've talked about it. Maybe we could share it with the viewers too. Like, what exactly? How does it look like? So, any type of demo.
So should I share my screen first, or do you want to do it
Um,
there?
okay, just show them this package that we're going to be
So
talking
sure, sure. So what we want to show now is sort of like how we have achieved real time. So you see this package with this marker on here.
Mm-hmm. Mm-hmm.
We're going to show you how in real time we're able to basically track this. So I think Alan's just setting up another computer. He's going to join this call from his computer and then share the screen.
Cool.
And then we'll be able to see in real time as he's moving it.
Okay. Cool.
So are you in?
Yeah, can you enable screen sharing? Sorry.
If you just enable screen sharing for us, then we
I
can,
think, I think you're good now. Yeah.
there you go. So
Okay.
as you can see, I'm going to put my hand there now just to show you that it's real time. Where's my hand? And then you see this, even when I like move it, it's able to track. It's able to track the code, even when it's like bent.
Even if we include it.
Mm.
Even when the finger's going over it, we're able to track it perfectly. While through movement, which it's just impossible with QR codes. You can't. You bend the QR code slightly. Like, is it okay if I share my screen now?
Sure. Yeah.
Okay, so I'll show you a couple more examples of how this could possibly be used. Remember when I said AR, VR?
Yeah. Yeah.
Let me show you an example of what I meant by that. So here's here's what we can, how you can sort of do product demos if you have our markers on these. Like how we imagine it is basically it'll be printed along with the box. So you can now take up your phone to it, and you can scan it and be able to see the product inside.
Oh wow, that's cool.
Exactly, and as you're moving around with your camera, you're able to see the product size. So basically, this product comes in two pieces, so it's not the exact size. But you need to know how big your blender is. You need to know how big that pot you're buying is. Just go up with your camera, scan the image, and then you're able to see it. And then let me show you a bit of example of what you wanted to see with the healthcare side of things, right? So as you can see, we're able to use DNA to track a suture thread. You see this thread? So as doctors, surgeons perform their procedure, these apical tags are no longer needed. They're for the earlier iterations. We can do it completely with our markers now. But as you can see, through this string wrapping around itself 2 to 3 times, through it self-intersecting, when a thread is over another thread, even humans can't tell them apart. And it's able to like track it through. So everything you see, all these colors you see, we can transfer it over into a digital virtual world. And just as a final example, here's how long it takes, even though it's not even that bent, it's not even that bad. Here's how long it takes for it to like here, we're trying to scan it with a QR code. And then, yeah, finally, after like 10 seconds, it's able to track it. The QR code is recognized. Ours, it's recognized all the way through. You put your finger over the top, no problem. Occluded, no problem. And you can see it moves along with the surface as well.
Mm.
So yeah, this is an example of how our markers can be used.
Wow. No, that's pretty amazing stuff. Like,
Yeah, and
amazing
guess what?
stuff.
We're the only people in the world who can do this. You know,
It's
we're
pretty
the only.
amazing
You will
stuff.
not see this anywhere. You show this to a computer vision expert, they'll be like, "How did you do that?"
Well, hopefully, more folks will learn about the technology that you two built here today. So,
Yeah, no, absolutely.
yeah. So I guess one of my questions is, so it sounds like let's take a step back, right? You guys started this really entrepreneurship journey, right?
Mhm.
I think you're building something really amazing. I guess, did you guys like always had that within you, like more about yourself, like what made you want to do it, right? Like
Sure.
it's something like tell us what.
I'll tell you a bit about our history. Me and Alan, we met 8 years ago, first year undergrad university, and we both wanted to get into that entrepreneurship. He was making video games and trying to get into the App Store. I was trying to make a delivery service similar, like this was before Uber Eats came out. I was trying to make Uber Eats, but in U of T, like a local one. You know what I mean? We were always within that thing, but we both realized and we both discussed it. We would get that industry experience first, and then come back, create our own company. That's what I did. I joined a startup. I was the first engineer in my biomedical company. He along with his PhD, works in basically a two-man consultancy group where they do robotic solutions for factories and factories. We both wanted to get that real life experience, get like a solid mentor who can teach us before we started our own company. And now is the time. We've got the experience. We're confident in our abilities, and we have a shared vision of what the future looks like. We both believe in automation, AI, and we both hate crypto, so it's perfect.
Got it. So sounds like you went into industry, got the experience from it, right? I guess my question was like, was there anything, like you said, right? Mentorship, right? What was that something that was pretty critical that you were able to gain from your experience? What's your perspective, in terms of mentorship to, someone who wants to, build their own business or go into entrepreneurship, like your thoughts? So,
you want to talk a bit about it? I feel like I've talked a lot. What do you think? Or I can keep talking.
No, Alan, it's your turn.
Right? So much.
In terms of mentorship, I would say I learned the most, honestly, working on my own, first of all. Like in terms of PhD, that was it's really learning experience. You're really in charge of your own research, right? Your professor is just a mentor, but you really like own up to your work. You're the expert in that sense. You need to advance the field with your work. So in that sense, I was able to learn just how to figure things out on my own, how to be like a one-man team to develop the entire software framework that we're using right now.
I'm going to add on to that. I'm going to jump in and add on to that. I was the first engineer in my biomedical company. Now we have like 50 people working there. I have 2 engineers under me and everything. But that statement that he said, you have to do everything yourself. It's completely true. I had to for example, I need to develop something. I had to source a camera or something for it. I had to go look for it. I had to go purchase it. I had to go do everything. I was telling my friend about this. Like, oh, you guys don't have a purchasing department? No, there's no purchasing department. It's a small company. You have to do everything by yourself. Your boss helps you. Your boss guides you. Your boss is like, okay, this makes sense. But, ultimately, you're reliant on yourself to basically make all these decisions. So I would always encourage, if you're looking to make your own startup, join small company where you're given a lot of responsibility. I'm fresh out of college, and they put basically their new medical device that they want to make on my shoulders. A lot of responsibility. You got to take it. You got to own up to it, and you can't blame anybody else.
Well,
there's no such thing as out of scope. There's no such thing as out of scope.
Got it. No, I think those are really good examples. I think, like you said, right? Like, I think it's you guys built that, right? Built those skills. That's why you're, really able to deliver the technology. And really, I think, like you said, well, like startups and entrepreneurship, it's like all about ownership and consistency and persistence. Like, honestly, like you don't have any of that, it's not going to work.
Absolutely, man. And one more thing, you gotta have that passion. I'll tell you this quick story. I gotta tell you a quick story. So when we found this out, when we were like, okay, let's work on this. We both took like 2 weeks of vacation time to basically just focus on this, right? So for those 2 weeks, 9 a.m. to 3 a.m. every day, we were just working on this. 9 a.m. to 3 a.m. every single day, just working on this for 2 weeks. And those honestly was the best 2 weeks of my life. You know what I mean? I went back to work the next day. My vacation's done. Our tracking system worked out. I'm happy. But the second I went back to my work, I was sad. I was like, what am I doing? And my work isn't boring either. I'm in cancer research, medical devices. It's cool. But I was sad. I was like, no, I can't be doing this, Those 2 weeks were so amazing. And yeah, that's why we're like, yeah, we got to go full in. That's why we're looking for this investment, the seed investment, so that we can. Right now, we're working 40 hours, full-time job, 40 hours in our startup. I'm not happy with the progress. We need to put 80 hours into our startup, That's why we're looking for that seed funding.
Got it. Well, like that's that's a lot of hours. I just don't wonder. Yeah, but overall, like I totally get that. Like I think we feel the passion that you both have around the technology you built, and I think, like you said, it's there's a lot of good adoption uses around it. Yeah. Is there, I guess, from that aspect, you said basically you're sort of looking for that seed round type of funding, right?
Yeah, basically.
Yeah. What do you hope to do with the seed round? Like, are you like,
yeah, so with the seed round, we're basically hoping within the 6 months, not even hoping, we have it planned out, that we're going to provide a robot which can sort items in one of those small companies we talked about before, help them sort these packages for them. So they don't need to have basically an automated solution for package sorting using our computer vision platform. That's what we're going to provide in 6 months. And then using that as an example, we're going to scale it up, pitch it to other companies, larger companies, Amazon, Canada Post, DHL, FedEx, whichever. Scale up by showing them what we can do for smaller companies at very low costs, where we are able to achieve.
Got it. Okay.
And then, of course, we're also looking into the AR, VR space as well. But our plan for that is mostly to, help them implement our platform into an AR, VR startup. So, if any AR, VR people are watching this, feel free to reach out to us.
Yeah, like let's talk more offline too. Maybe there's
Absolutely.
folks I could be a resource, to connect you guys with.
Absolutely. I'm more than happy to talk to anybody.
Yeah, I think probably couple more questions. I think one is definitely, since you guys are so deep into, computer vision, robotics, and really AI, right? I think, like, what are your thoughts around that? Like, how do you think it's going to keep, changing, and where are we going with it, I guess?
I'll pass this question on to the robot god, basically, right here.
So I mentioned earlier, I'm doing my PhD in machine learning. And actually, the approach that we're taking for our marker system doesn't include machine learning. So my view is that after researching about 4 or so years into machine learning for computer vision, it's mostly not ready. Like how self-driving cars they always seem to be a couple years out. My view is that we still need a breakthrough in order to see these systems deployed in the industry, especially where you need reliability of like 99.9%, like say in a production line, right? Where if you have any failure case, any misdetection, you're holding up the entire line, and that can cost like thousands of dollars. Yeah, so my my view is that you should go as simple as possible. And if you try everything, all the simplest approaches, and it turns out it doesn't work, then it may warrant some more complexity. And possibly after a few more tries, then maybe you need machine learning.
Hmm.
But yeah,
That approach where they're just trying to, they're like these startups, they're just like, oh, we have machine learning. We're going to use machine learning for this, machine learning for that. It's not right. It's not true. It's basically trying to sell a dream,
Hmm.
like they're trying to implement machine learning in places where you don't even need machine learning.
Hmm.
It's almost like they're trying to sell to investors and not to actual customers.
Hmm. Hmm.
And yeah, if you really follow what customers want very specific requirements, and customers want reliability. Machine learning won't give you that yet.
Hmm.
Our step, what we're trying to do is sort of like intermediary step between the full autonomous general robotics and what we have now with it being done manually. The intermediary step where robots are able to use markers to see where they are, and then eventually, once we have enough data from there, we'll be able to implement marker-less solutions.
Hmm.
But trying to jump from nothing to machine learning, it doesn't make sense.
Hmm.
You need steps along the way, and that's basically we're the step before markerless.
Hmm. 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 So from that, it sounds like, we're still have a lot of incremental progress that we need to make. But
Absolutely.
hopefully one day we'll get there soon enough.
Yeah.
Cool, cool, cool. Well, I guess, is there any other thoughts and anything you guys want to share before we close? So, yeah.
Huh. Do you have any thoughts right now? Do you have any last minute share? I have a lot to share, but I feel like I talk too much, So like I'll leave it up to Alan if he wants to share anything.
no, go ahead.
No. I'm good. I think I've spoken enough.
Cool. No, I just really appreciate, having you guys on and really,
We're really happy to be here, Hubert.
talk to us about Dawn Robotics, and also actually sharing us a real demo on the video. So it's really good and awesome. So yeah, no, thanks for coming. So appreciate it.